I guess we're live now on Twitch. So welcome everyone for our weekly live stream on Twitch. Joining me today is Stephan, who is working on the .NET client. So welcome, Stephan. How's it
Hi.
going?
Fine, thank you.
Good to finally meet here on Twitch. I guess sometimes it's like, it takes long to basically prepare for this schedule and get all talks scheduled. So we're really excited to have you here today. Perhaps we can do like a little bit introduction about yourself. Where are you based and how long you joined Hazelcast and what you're working on?
So I'm based in just outside Paris in France. I joined Hazelcast 4 years ago, maybe. And I'm originally working on the .NET client and everything Microsoft .NET Windows. And this is expanding more and more into working everything what we call polyglot, like having Hazelcast, which is mainly Java, support all sorts of languages like Python, .NET, JavaScript, Go, etc.
Okay, so from your experience, like for anyone who is listening to us here today, Hazelcast is based on the Java virtual machine. So from your experience, what would you say is most important part when it comes to .NET?
I think the most important part is to realize that at the moment you can really use the Java cluster without knowing that it's Java, and you can use it from .NET. And this is one of the things we're going to see later in this talk, is that it's you basically can ignore that there is Java, just like when you use the Oracle database, you don't know what language it's coded in, you just use it from .NET. So usually people tend to say, well, I'm a .NET developer, I don't want to use a Java product because this is not my world. Well, you can use the Hazelcast product as a product, just ignore its Java, I would say, because there is no problem or difficulty using it from .NET.
Okay, so for anyone joining us now, feel free to leave your question in the comment section below. I will take these questions and forward it to Stephan. So with that being said, I'll let you start, Stephan, your slides.
Okay, I'm going to share my screen. Can you see my slides? So
Yes.
you've already said all these things. As Fawaz said, please feel free to type questions in the QA panel and we'll try to answer them. The webinar is recorded, so you can watch it later or share it with colleagues if you find it's interesting. I've already said it, I'm Stephan from the engineering team, working with .NET things and more generally everything polyglot in terms of client. And we're here to talk today about migrating from Hazelcast .NET Client version 3. We're going to migrate to version 5. Why talk about it now? Because version 5 is currently version 5.3.2, I think, and I think we have 5.3.3 in the making. Version 3 is very old. Version 4 was released 2 years ago. Version 5 was released 1 year ago. So again, this is long. So why now? Well, it turns out that by internet times, it is a very long time. But if you are a large company and you're running large enterprise solutions, it may be the time it takes for you to evaluate the new solutions, plan, start thinking about moving to a next version. We are currently seeing more and more enterprises migrating today. Like no one was migrating a year ago because version 4, version 5 were brand new. So I think it's really about time companies start worrying about upgrading. So it's the right time for us to talk about it. Version 3, you have to realize that it was a straight Java port. So basically the idea was we want people to be able to use Hazelcast from .NET. We port the Java code with all the Java patterns and conventions and weird way of coding. So if you were a .NET developer, you would not feel at home. You would feel like this is weird. This is we were not using .NET properties. We were using not using camel case because Java is not using camel case. All that type of things. I was using threads explicitly, totally bypassing the thread pool, again, because this is what Java was doing, which meant that from a performance point of view, it was not ideal. So it was working. We have very, very large customers, but we knew it had some issues, and it was fully synchronous. Fully synchronous code, meaning blocking threads everywhere. Again, you can work with that, but we knew it wasn't really perfect. In the meantime, Microsoft was going full into asynchronous code in their whole stack from enterprise level to network and a very low level code. And they were doing another thing, which is provide a ton of libraries, which I call Microsoft extensions, everything like logging, dependency injection, et cetera, et cetera. Tons of things that Microsoft is basically giving us for free. And this is becoming the .NET ecosystem. So if you do logging today, you expect it to be the natural Microsoft way, et cetera, et cetera. And our client, version 3, was more and more not aligned with the typical C# way. And Microsoft is, for instance, I mentioned Kestrel here. It's their new web server. It's totally based on .NET Core, and it really reaches the top of the performance benchmark regularly because it's based on asynchronous, and it's on asynchronous code, and it's based on their own extensions. So this is where we want to go. We want to embrace the ecosystem of Microsoft. We wanted to provide a very idiomatic C# experience, like you would feel at home, feeling this is normal C# code. I don't have to pay attention to the fact that the server is running Java, because what I'm using as a client it is really C#. So what this means is that the client beyond version 3 is changing a lot. But it's the same Hazelcast, so all the concepts are the same. We haven't changed anything. You still have a client using map, using lists, etc. It's just that it's done differently, and it's done in a way that should feel easier for you as a C# developer to manipulate. So what this means is that there is no direct upgrade path. You cannot just flip the NuGet package and expect it to work, but there is a migration path, which is a pretty silly one. You just have to respect some conventions, and then this is going to work. So it's a very charted migration. I'm going to show you some of the differences and how, well, what migrating means in this demo. So you should be able to see my Visual Studio screen. And this is a typical program that you run with client 3, where your main method is basically calling an example method, and that example method is going to create a client. So it's going to see Hazelcast client, new Hazelcast client. Here, the options, all the configuration of the client, etc., is coming from a special hazelcast.xml configuration file that you need to have around on disk. And then you're going to obtain a map from this client. You say client get map, and it returns a map. You put a value. So basically, for those that are not aware, the map is like a distributed dictionary on our system. So you put a value for that key, and then you get the result. So that's a very simple, I would say, example. And if you look at my NuGet, it says this is running on version 3.12.3. What I'm going to do is click on upgrade here, and this is going to upgrade NuGet. So you can see that it's going to download many extensions provided by Microsoft for logging, for using the file systems, for configuration, all these extensions that Microsoft has been polished and optimized all the time. So we're basically building on top of Microsoft's work. If I go back to my program, we'll start to see some problems because, of course, as I told you, it's not directly going to work. This is not the way you get a client anymore. You get a client, so I'm going to copy code from here and there. So I'm going to remove that one. You get a client by using a Hazelcast options builder, which is a class that is going to build options. And and by asking a client factory to start this client. That one should not be red, but it's red. So one thing you're seeing here is this red squiggles here. Hazelcast is complaining. So two things. The options here is built on top of the Microsoft configuration options system, the thing that is introduced by the Microsoft extensions.configuration abstraction. It means that these options could be in the app settings.json file, or they could be in a hazelcast.json file. They're not in an XML file anymore. We're switching over to JSON because the whole .NET ecosystem is switching over to JSON. What this configuration platform offers us is that it also supports injecting the command line. So here you see that my program is getting arguments. I'm passing these arguments to the option builder saying, hey, please use these arguments. This could allow me to change any option at runtime. You don't have to do it, but if you do it, it's going to work. It's also working with environment variables. So any option that you can set in Hazelcast can be set via environment variable. This is basically respecting the normal options that you have in Microsoft. You could even dependency inject these options. If you know how options work, well, this is exactly how they work here. So that is the first thing. Going from XML to JSON is not too painful. This, for instance, is the old configuration file where you would say this is the Hazelcast client. There's a network with members and there are addresses. This is where I want my client to connect to. JSON is exactly the same structure. I was going to say this is Hazelcast and this is a network and this is the addresses. So again, we're not changing the concepts. We're not reinventing Hazelcast. We're just changing the support. It's JSON, not XML, but moving from one to the other is a pretty boring task where you replace the brackets by JSON syntax. So if I go back to my program, the next issue that I see is these annoying things here where it says you cannot use await here because await needs to be in an async method. So we're moving over to async. Everything in the new client is async, down to the very low I/O networking IOs. What this means is that when we're waiting for the server to send us a reply, we're releasing the thread. It goes back to the thread pool and it can be used by another thread. We're not managing our threads anymore. We're entirely depending on the thread pool, just like Microsoft SQL client is doing, just like their web server is doing, just like pretty much anything is doing. So we work very well with a web server. If you want to use Hazelcast within like a web API, this is going to work. But we're fully async. And as you know, being async has its own issues. It's viral, like you cannot await in a normal method. So I'm going to have to convert this method to an asynchronous method, saying, okay, this is an async method, and then await is fine. If you follow what I'm doing here, client getMap doesn't exist anymore because it's called getMap async, because we are doing an async thing. And because we are async, we have to await the results. Here, I'll put a value. Well, it's put async because I am now async, and I have to await that task. Getting a value, you can guess that's going to get async. And of course, if I want the value, I need to await the task. That is all I have to do to convert my method from synchronous to asynchronous. So I'm now using the new client. This is not more difficult than this. So usually what you'll have to do is add some await keywords here and there, and then add some async at the end of the method. All the methods are the same name. You still have put, get, set, etc. Just it's now renamed async, but it works exactly the same. What we see here at the top is that example is like it has a blue squiggle. It's basically telling us that, well, this is an async method, but I'm not awaiting it. So I'm going to fire and forget the task. And the program is going to end, and I have no idea whether my task will complete or not. So I have to await the task to make sure it completes. Aha, but becomes red because this is not an asynchronous method. It returns void. So I have to convert it to an asynchronous method. And now we're happy. We basically have converted our example into an async one. And this is basically all there is to say about migrating from version 3 to version 5. This is all you have to do. So all your code that is doing get in a map, put in a map, get in a list, if you're using fenced logs, if you're using logs, all the things that Hazelcast is proposing to you, it's not more difficult than that. So it's a lot of probably typing and changing things, but there is no big difference. So it's a no-brainer, I would say, migration. It's not an upgrade, but it's a migration. One thing I wanted to show you is a few things that we still have changed a little bit. So one thing that we have changed is events, the way you subscribe to an event in a map, the way you say, please do something when an entry is added to the map, for instance. This used to be, again, something that we called it listeners in version 3, and it was a class that you would register against the client saying this is a listener for events, which is totally not something that C# does, but it was really there to mimic the Hazelcast way of doing things. So what we wanted to do is migrate to something that is way closer to the normal experience that you have with C# when you're using events. And when you would do map.entryEditor, ideally, you would do, if you have a map, you would do map.entryAdded plus equals sender odds. And then you would process the events. This is the typical C# event. The only problem that we have is that subscribing to an event is an asynchronous operation. We're telling the server, please send us events. So it cannot be totally synchronous that way. It cannot be plus equals. So we've done something that is very close to this syntax where we say, we await the map, please subscribe to entry added. So when an entry is added, run this code. So I could say, okay, I'm going to write the value that has been added, for instance. And if the entry is removed, I'm going to write the key that has been removed. So we're switching to a model that is way closer to the natural experience that you have with C#. It's way lighter to register an event compared to what we were doing with version 3, where you had to create a special class, implement a special interface. So what we expect is that migrating from version 3 to version 5 is basically you're going to remove plenty of code and move the interesting part, like business part, in like this area here. So we have many events. All the events that you have in version 3 are still in version 5, entry added, entry removed, entry modified, etc., etc. These are the events. Another thing that I need to raise to attention is logs. So in version 3, the logs are thread-based, just that the typical log keyword in C#. Where the lock is related to a thread. If you have done asynchronous code with C#, you probably know that the lock keyword doesn't work with asynchronous code. One reason being that when you await a method, you will return, but you may not return to the same thread. So basically, each time you await something like a network operation and you need to wait, the thread that was running the code is returned to the thread pool, and when data is available, another thread is picked from the thread pool. You're not sure it's the same, so you cannot log per thread. So what we're doing is we're doing it using what we call an async context, which represents a context in which you log things. So by default, all our code runs in an async context. Whenever you create a client, it creates a context. And if you want to switch to another context, saying this is something that is exclusive with the previous operations, there is a syntax here, which is please use a new context for the operations that happen within this block. So everything in here is running on a different context, and that context is exclusive with the previous one and with any other contexts. So this is a different way to handle locks. You need to do it explicitly. This, unfortunately, although annoying, is a consequence of using async, and it appears everywhere in Microsoft code. We're slowly getting to the point where you say, yes, but I have done a big library and everything is synchronous, and I'm not going to refactor my entire application. So let's take an example. You have created a cache in your application. It's a very basic cache. I'm not looking into how you populate the cache. Let's just say that you initialize the cache with a map that is contain key and values. And what you were used to do, you would say, I can get a value for a key, and it would get it from Hazelcast map. And this class is your abstract cache. So the rest of your application doesn't know about Hazelcast. You don't want to depend on Hazelcast as a major dependency. Maybe you were thinking later on we may replace Hazelcast by a competitor, so let's abstract Hazelcast. Let's have just that cache class. And that cache is fully synchronous, and all your application is depending on it, and you're not going to rewrite the application to be asynchronous. So you're not happy about us moving to async. So you think, how am I going to do this? So, sorry, this should be an HMAP. So what you're saying is you've heard what I said. You're going to say it should be get async, and you need to await the value. But if you await here, it's going to tell you you have to replace this string here by an async method. But you don't want it to be async, because you know that if it's async, then all your application methods that use the cache have to become async. So what you're going to do is you're going to look at the internet, and I'm going to say, there is a pattern which is that pattern. And I don't have any red code anymore. So this is working. Everything is happy. So I can just change my method here, and this is going to work. So this is interesting. Some people will tell you this is absolutely horrible, because you're basically forcing asynchronous code to behave as synchronous code. That being said, if you look inside of Microsoft's own libraries, you will see that they do it a lot when they need to convert from synchronous to asynchronous and vice versa. So this is not totally horrible. This is the way to do it. The only thing is you have to know about the consequences. When you do this, you're basically blocking the current thread. So it will stop here. It will not await until the get async, which is going to run in the background, can complete. So this is safe in most situations until it is not. So what we've seen with a few clients is that when you run on ASP.NET, that type of things deadlocks. So why does it deadlock? The reason is a bit confusing, but it's mostly that when tasks are running, they are running within a task context. And you need to be aware that the default context has many threads to run tasks. So when a task needs to run, it will grab the thread and run. When you are in ASP.NET, there is only one thread per request. So if this is running within a request, then when get async is going to complete, and it's going to need a new thread to continue, there's only one thread, and it's already running on that thread. So it's going to deadlock and not work at all. So without entering details, there is a way which you can see here, which is basically there is an async helper, a method that allows you to encapsulate the call that you're running and it makes sure that you won't have problems with the threads. So this is something you need to be aware. There is a solution. The solution is not very complex. It's not entirely a hack, because this is the solution that Microsoft is going to tell you to use. But you need to be aware that you need to use that solution in some cases, especially if you're doing ASP.NET Web API code. If you're doing basic console code, that will not be needed. We provide the code for this async helper, which is pretty, you can see it here. It's a very small class, so we provide it and we document it, but you need to know that you need to do it. The good news is that once you've done this, and if you run enough tests, well, you can basically manage the impedance mismatch and say, okay, part of my code is going to migrate to the new async of Hazelcast because I want the performance, but part of my code is going to stay using the, I would say, legacy synchronous methods because I cannot rewrite my entire business layer just to please Hazelcast. And that is about all I wanted to show you, like the key things that I wanted to show you about the differences between version 3 and version 4. So if I come back to my slides here, the takeaways, things to remember. The migration is not transparent. So we're sorry, we cannot offer a completely transparent migration from version 3 to version 5. But I would say the future is inevitable. The future is asynchronous code, because this is what's going to provide performance. For instance, our low-level networking code layer comes directly from the Kestrel web server. So we're using what's the fastest ever networking library on .NET, but it's async. So I would say you will have to migrate. We provide ways for you to do it without rewriting your whole application. So we have a documented migration path that can be done via phases. Like you could rewrite part of the low-level code that access Hazelcast and make it asynchronous while keeping part of your application synchronous, because it's a big enterprise application. And later on, steps by steps, you would like propagate the asynchronous code everywhere and gain in performance, but you don't have to do everything right now. We totally realize that this migration is not obvious, so we're really committed to help, and we're trying to, alongside Microsoft, that are doing an amazing work at explaining people how to do it, because they realize they have to do it. So how can you do it in a nice way? We're committed to help. We're listening to feedback. We have a complete documentation for the new version, version 4, version 5. Compared to version 3, we have totally rewritten the whole documentation. And this includes a migration guide from version 3, where everything I've presented today is explained, including, as you can see on this slide, a list of asynchronous pitfalls, like problems that you may see with using asynchronous code, things that you want to avoid to do. You will find the code for the helper that I've mentioned before, also on this page, and you have the link to the documentation here. We're listening to feedback, so whenever someone tells us you could help us greatly by, I don't know, adding something to the client to facilitate using asynchronous code, we're willing to help. And with that, I think, Fawaz, I am going to be open to more questions and discussions about this migration path.
Yeah, that's great to hear, Stephan. Thanks very much for the information. I guess it's just like you mentioned, it's going to take some time, but obviously this is a clear path for documentation. Obviously, the Slack community as well is good place to ask questions. Is that right?
Yeah, we're answering on the community Slack to any questions. You will notice that I haven't spent a lot of time explaining all the different features and everything. The experience we have with customers today, some in big banks that have tried to migrate, is that simply migrating is straightforward. They looked at the doc and they basically say, oh, I just need to use async at the end of the methods and change a few things and it works. Okay, this is, I understand, no question. The only issues that we're facing is this migrating to asynchronous code, where people well, there are pitfalls, things that you should know, don't do this, etc. So this is what we are really trying to document, and where we're helping people on the community Slack. It's not Hazelcast specific, but we're willing to help.
Okay, that's great to hear. So I've got a couple of questions. I'm just gonna pass over these questions to you and see what you think about. So first question is regarding locking. So someone has asked about explicit context and fenced lock. Any comment on that one?
Yeah, so locking is a annoying situation in async code in .NET. For everyone that knows, you cannot just use the lock keyword. That was magic. So you have to maintain some sort of context one way or another. For fence lock, we have an explicit context. So we have a lock object, a lock context object. You create it, and then whenever you lock, you say I lock for this object. It's sort of a mutex. And then you can release the lock on that object, and you need to pass that object in your code. And it's very easy to use because you see exactly what you're doing. So it's not, the only annoying thing is that you have to pass it around in your application. The easiest thing is that you clearly see what you're doing with your lock. So for fence lock, it's very explicit. For maps, it's different. We thought about doing it in an explicit way for maps. But that would mean that every time you get something from a map or put something in a map, you would have to pass this lock object in the method. Let's get this value, but within this lock context. And it becomes very tedious. And basically, when the code was reviewed, people at Hazelcast say this is really not friendly. Like most people don't lock their maps. They just want to use the map naturally, make the context implicit. So there is an object like fence lock, but it lives in some sort of asynchronous context, and we manage it for you.
Okay, that's good. And for events, can you talk a little bit about partitions, partition lost and partition updated?
So what I've shown here is I was subscribing on events. That's the concept in the new client. I would say you subscribe on events. I was subscribing on events on a map. So I say map.subscribe, and then for each event, I can have a handler that does different things. If you have a topic, you can subscribe to, you do topic.subscribe, and you can subscribe to events. The client itself also supports subscribing to events. So you can do client.subscribe, and there you have all the events that you're talking about, like partition lost, partition whatever. You can subscribe to client disconnected, client reconnected, all these events that don't depend on a specific distributed object, but on the client. There is a subscribe method on the client itself that will allow you to subscribe to them. And then you handle them much in the same way with a handler.
Okay, that's good. So one question also regarding logging. So I assume the .NET client uses the Microsoft extension logging. Is that correct?
Yeah, that is correct. What that means is that we are writing to logs, but when you create your own application, you can find that in our documentation for configuration. You have to create, I would say, the sink for the log, like where it's going to go. By default, we are writing to the log, but that's all that happens. So nothing comes out. So you will have to say, I want to have a console logger where everything that goes to the log goes to the console, or it goes to a file, or it goes to wherever you want it to go. Our idea is that by using this, it means that if your application is already logging using Microsoft logging, well, we will fit into this pattern and our logs will go there. And if you want to redirect the log to database, there are providers for that. But this is, again, the idiomatic Microsoft experience, not Hazelcast. We have no value providing logging. So we're just using what Microsoft is using.
That's good. So one final question regarding the 5.3 version. So what is the most exciting feature or enhancement for the update, would you say?
In 5.3, so it's no secret that we 5.2, 5.3 is mostly tracking the server. So whenever there is a new version of the server, we have a new version on our side. But I would say that we've worked a lot on SQL and LinkU. So you can now totally do SQL from .NET, including LinkU. So if you have you want to query your map, you can basically use a LinkU query, say map dot. So I think you have to do map dot as queryable dot where, and then you use lambda expressions. So we basically have a LinkU provider. You need to benchmark this solution because, of course, everybody knows that LinkU can be slower than raw SQL. But on the other hand, during development phases or for experimenting, it's amazingly performant and efficient. Like you don't have to think about writing SQL, you just do LinkU. That's a nice addition.
Yeah, that's great to hear. I think this is quite important to basically try it out and see how it works. So as we mentioned today, if you still have any question, you can reach out to Stephan on the community Slack or join us on the Twitch. And we'll definitely have some blog posts about the same topic as well in the near future. So with that being said, thanks very much, Stephan, for your time today. I think it's been great to have you here on Twitch, and we look forward to seeing you back again here. Thank you.
Thank you, Fawaz.
All right,
Bye.
have a good one. Bye.